Today on Engine Power, we'll finish up our budget LS build and see how much power it makes with 3 different ways to feed it fuel. Plus, it's back to the Holley LS Fest, where skills and egos are on the line at the yearly Engine Swap Challenge.
Hi, welcome to another round of Engine Power. We're back on the hunt for a respectable LS power with a rock-bottom budget. You see, it's a project we started last time when we brought in a 4.8 LS from the Boneyard. After an inspection of our used parts, we were satisfied that the bottom end was in good shape. Then we had this welcome surprise, a pair of factory LS6 heads to work with. We sprung for a much more aggressive cam from Comp, along with industry standard replacements like the timing chain and oil pump. We bead blasted the heads, dressed their deck, lapped in the valves, and touched up the intake throats. Then we installed a new Summit valve spring kit with stiffer beehive springs. And after a trunnion upgrade, reinstalled the factory rocker arms to finish up our long block.
At this point here, we're only about $1,500 total into this engine project. We've got $275 in the long block, plus the coil packs, and a little over $1,200 in go fast parts. So today is our payday. We're gonna get the top end finished and get her strapped to the dyno. And we're gonna go over a couple of the most common ways guys are getting air, fuel, and spark into these little LS engine swaps. And hopefully get to that 375 to 400 horsepower range. We'll see.
And those 3 things include a street-friendly Holley carburetor with vacuum secondaries and an electric choke. The second is a more street strip-oriented carb. It's a double pumper with mechanical secondaries and a mechanical choke. Third is Holley's self-learning electronic fuel injection. Now at this point, if you don't have the induction or fuel delivery, that's where you're gonna spend some dough. Our intake manifold is a dual plane piece with cathedral ports. Now we've used it on several dyno engines. It accepts OEGM intake gaskets, and here's a quick little tip. By putting a thin coat of WD-40 on the head surface, this allows the gaskets to walk and seat, making a perfect seal. Torque the bolts to 11 foot-pounds in a crisscross pattern. To control the ignition and timing, a 6LS2 that mounts on the cast-in bosses on the intake.
Now that box mic just installed is for a 58 tooth reluctor. Now a lot of the older style engines use the 24 tooth. So how do you tell the difference? It's quite easy. Now the foolproof way to tell is to look at the color of the crankshaft position sensor. Gray is 58 and black is 24. Now if you're looking in the junkyard and all this is covered up with mud and grease, well if the knock sensors are down here by the old pan rail, it's 58. If it's up under the intake, it's a 24. Now both sensors are Hall effects, which use 3 wires, positive, negative, and a signal. When the reluctor's wheel's teeth pass by the sensor, that's when it interrupts the sensor signal. It sends that information to the PCM, or in our case, the MSD box, to determine the position of the crankshaft in relation to the number 1 cylinder.
To cover the valve train, Proform's new valve covers just for the LS with a full-length oil-restricting baffle underneath. They're taller than stock to fit larger aftermarket valve trains. And that killer textured powder coat finish looks good on any LS engine. Plus, they come with the hardware for a center bolt mounting option. On the side are threaded mounting holes for the addition of these ignition coil brackets. The brackets are an add-on and raise our factory coils so you can sport that Chevy logo. Now, we didn't get the coil harness with the coils, so this aftermarket set will fill the bill. From the ignition controller, we run the harness to the passenger side and make the first connection to the coil harness. Then the crank sensor. The map sensor doesn't get used. We now connect the driver's side coil harness. And finally, the cam sensor. Before we add plugs, wires, and headers to this thing, there's an oiling concern we need to address that relates to swaps like ours. There's an in and out on the oil pan that's designed for factory oil cooler lines. It's also great for drawing oil pressure, running an oil temp sensor, or even supplying oil to a turbo. We need to address this now because once the header's installed, there's not enough room to get in there. Whatever you do, you can't block this thing off with a flat plate. You have to connect the in and out with an oil bypass plate. Now we're going to have continuous oil flow and won't have to worry about oil cooler lines.
Our budget 4.8 is ready for its trip to the dyno. And close behind are the 3 fuel delivery pieces we'll test out when we come back. I'll need yours for just a second for one when you're done. We're back, hooked up, and ready for the first of 3 fuel adders. Now each one has its place, and we'll see which one works best for this engine. Because of where the MSD box is mounted, we have to run a carb spacer so the carburetor clears it. Now it has to be in the right orientation, and we'll run the spacer on all 3 fuel adders. First up is the vacuum secondary 570 CFM carb. Seems small? Well, the engine is only 293 cubic inches. A carburetor CFM rating is based on how well the engine breathes, or its volumetric efficiency. Now, a performance engine like ours has about 85% efficiency at maximum torque. So on Holley's carb chart, we're going to turn the engine 6,200 RPM, and just below 300 cubic inches shows that we need 570 CFM. Only one switch 12-volt hookup is needed for the ignition box, and we'll use the laptop to build a timing map using the MSD software. We'll put 23 total degrees in for now. We're filling the engine with Royal Purple XPR 5W30 from our Goodson priming tank. We're pumping 89 octane through the system to get along with our 10.5:1 compression ratio. Stabilize 6.4.
Yeah, buddy. Okay, you ready to fire up?
Here we go.
Let's do it.
We're off to a smooth start, and after we confirm we're running on all cylinders, we'll crown it with our stack that houses our air turbine. All that's left is to get it up to temp and see what this combo can do. The first pull will be a sweep from 2,800 to 6,200 RPM. The vacuum secondaries open up around 3,200 RPM, and we maintain good oil pressure. I think sounded really good, loaded up really nice.
Yes, it did.
343 on power, 312 foot-pounds of torque.
That's not bad for the first pull.
Let's do another. Now run 2 was just as smooth, but gave us better numbers. 356 on power, 317 on torque. Now this third run, it's either going to stabilize or climb a little more, so let's see what it does. Everything is the same as far as temp, RPM, and timing. 355 horses, 318 pound-feet of torque. Now we're going to add a degree of timing, from 23 to 24 degrees. Now the engine was still climbing in power at 6,200, so we raised the sweep to 65. 367, 319.
We just got started.
This little 570 had excellent idling characteristics, and the secondaries came in nice and smooth. Now this little thing gave us the fuel delivery needed to make almost 370 horsepower on this little 4.8. That's not bad. That also gives us a good idea. This is an excellent carb for an everyday street driver. The price, $375. Now it's time to kick it up to a 600 CFM for another test.
Now this double pumper has 30 more CFM of flow, totaling 600. Now it's a mechanical secondary design with a manual choke. Now it's geared more towards the street strip application, but uses the same hardware as the 570.
Another fire up and back up to operating temperature. Now we'll run the engine from 28 to 6,500. It has the same 24 degrees of timing, so any difference we see is all carburetor. Out of the box, we made 370 horsepower and 328 pound-feet of torque. After 2 more unaltered pulls, it settled in at 377 horsepower, 331 pound-feet of torque. And this thing's awesome. Now, lean is mean, but we like it safe. So a jet swap is the next move. We'll change the secondary jets only from 73 to 75s to richen it up at wide open throttle. 374 horsepower, 328 on torque. Not bad to be back in the safe air-fuel window.
Now this 600 CFM carburetor was worth 11 more horsepower on the high side, 7 more in that safe air fuel window. Now $395 for this one, well, it's pretty good power upgrades for only 20 extra bucks. And we're not done just yet. When we get back, it'll be time for EFI.
Back in the dyno room and ready for the last of 3 fuel adders. Holley's Terminator self-learning fuel injection. Now the throttle body is 950 CFM and incorporates 80 pound-an-hour injectors. So this unit will support engines from 250 to 600 horsepower. Cast aluminum rails supply those injectors with fuel. Now Holley did something really cool here. Instead of having a bulky harness and having to make the connections to each one of the sensors, they pre-wired it for us into this single bulkhead. So one connection, it's that simple.
Only 4 loose wires need to be hooked up. The first 2 are the negative and the positive, which have to go directly to the battery post. The third is a 12-volt connection. This needs to go to a switched ignition source. And the fourth is a tach signal from the MSD box. This lets the EFI know when to fire the injectors.
With the handheld tuner connected, we can tell the ECU what our engine parameters are. All right, John, go ahead. Check wide open throttle. Okay. And set the open and closed position of the throttle position sensor. Now it's a fully self-learning, self-tuning system, and this is all you need. After checking for leaks, we'll start the engine and make sure all the cylinders are firing. The first order of business is to maintain a nice idle. Now we can make a short sweep from 25 to 4,000 RPM to learn in that range. Now we want a stumble-free load up and sweep. This system learns extremely fast, so that shouldn't be an issue. And it wasn't. 311 horsepower, 227 pound-feet of torque. The next sweep will be from 25 to 5,000 RPM. With the system doing its job, the engine made 322 horsepower and 304 pound-feet of torque. It's ready for more RPM. This time, from 3 to 6,500. What's another 1,500 RPM worth? No, you didn't. Look at that, it's learning 394, 324. Wow, 394 horsepower. And climbing like a bear still.
Man, this is a circle track little monster right here.
$275 at 4.8, unreal.
So today, we've shown you a couple of ways to throw fuel at one of these LS projects. Now yes, the carburetors did run pretty good and are definitely more affordable than the EFI option. But there is a reason why you won't find one on an OEM vehicle this side of the 90s.
Stepping up to fuel injection is more expensive, but it adds several benefits to the equation. Technology is one. There's a lot of specialized components, so naturally they are more expensive. Now a system like this that operates in closed loop is always going to correct itself. So no matter what elevation, humidity, or temperature you're in, it's always going to find that targeted air fuel ratio that you entered in. So a laptop is never needed.
And you can forget about using a choke, because those cold start issues are now a thing of the past. Now, one thing that you can expect is going to be an increase in fuel economy, which given enough time can actually pay for the unit itself. Now, these things will support up to 600 horsepower, and you can get yours for under $2 grand.
Up next, see the wildest, most competitive engine swap challenge around. 2 teams, lots of skill, but only one will claim the title. Stay with us.
Well, after you build it and dyno it, the next logical step for your LS engine is to drop it into a vehicle, which may mean swapping out an old engine, then lots and lots of connections before you can fire it up. But what if you were racing against the clock in front of an audience and hoping to win a new LS? Well, that's the whole idea behind the LS Engine Swap Challenge at Holley's LS Fest. Now, at the most recent event, 2 new teams faced new rules that made winning more challenging than ever.
They don't even know what the cars are until we hit the horn and they pull back the covers. Same rules as before, only hand tools. The guy that gets done first keeps the engine, and that's how it's going to go.
Since we don't know what we're exactly working on, we can't practice on anything.
I think it's probably a second-gen Camaro.
I'm going to be diving under the car doing the bell housing bolts and torque converter stuff, and he's going to be up top.
I've got a Camaro we've been playing with an LS motor.
And we kind of got laid out in order what we want to do it in and who's doing what and when, so someone's always doing something.
So we've been practicing a little.
Every year, our friend Chatty Chad Reynolds serves as the play-by-play guy.
2, 1.
Each car is an identically prepped second-gen Camaro with a factory small block. For a while, the 2 teams are on the same pace, but only for a while.
Is it a 9/16?
I think so. Terribly fast, but I'm worried about it now because they're underneath this thing, and they have been for a while. I'm not sure what it is they're trying to remove.
The new LS engine has a 6-liter iron block and a Holley high-rise intake that's got to come off for clearance purposes.
Now it's going to be a test to see how quickly they can get the new one prepared and in, because the silver team has got theirs on the hook and it's ready to go in place.
All right, go up. We gotta go up.
A lot of sunscreen needs to wear a hat.
All right, come on down a little bit.
The gray Camaro team endures a few fitment issues.
Dude, we gotta get these bolts stuck through. Bolts are too long, they're up against the firewall.
Bolts are too long, they're up against the firewall.
Somebody got brakes on?
Dude, they don't even have their motor in the car. Just make sure we get it right, okay?
In due time, they're dropping on the intake, slapping on a set of hooker headers, and wiring up the Holley EFI system. Then, like music to the team's ears, the blue Camaro team continues their swap because it isn't over yet. The gray team has to pass an inspection and take the car for a short spin to prove their swap was a real success. With an official time of 1 hour and 41 minutes, Pete and Adam have an LS prize to haul home. And bragging rights till next year.
The Falken Azenis RT615K was inspired by race-winning technology. Now, the advanced compound makes this tire great for both street and track use. Now, its 8/32 tread design is from Motorsports technology, and the solid support rib will allow more traction because more of the contact patch of the tire is on the road surface. Now, you can pick these things up from the tread source in over 20 sizes with wheel diameters from 14 to 18 inches.
For you 6'1" Hemi guys that want to make some big power, well, Edelbrock now offers a competition series supercharger system for the racer and tuner in mind. Now, it comes with a TVS 2300 supercharger, integrated intake manifold, as well as those big long intake runners to make that big low end torque. Now, it comes with a heat exchanger, air inlet system, harness, pump and balancer, but you're going to have to finish it out with the custom parts that you need to finish your kit. Now, you're actually going to see us use this system to try to break 800 horsepower later in the year, but if you can't wait, well, you can get yours for $6,500.
How would you like to improve your vehicle's braking 25% just by swapping out the pads? Well, you can if those pads happen to be the Greenstuff from EBC Brakes. They're designed to reduce brake dust. They give you a better pedal feel at low speeds, and they have this special brake-in coating that gives you instantly safe braking as soon as you install them. Now, they've got them for subcompacts, trucks, and SUVs, and you can pick them up at your local parts house. Well, time for us to head to the house. See you next time.